Keeper 5.5, vector functions. All right, so your domain of your vector value function is the domain that satisfies every piece of your function. So it's where all 3 or 2 or 10 components are defined. It just depends on how big your vector is, but you just want to check the domain of each one and then see where all of them are defined. So here's some definitions you guys need to remember about vectors. Your velocity is simply the derivative of your position function. Your speed is the magnitude of your velocity. Your acceleration is the derivative of the velocity. And then you have what we call a unit vector, whose magnitude is always 1. It's going to be your velocity vector over the magnitude of your velocity vector. Alright, so we have a particle moves in the xy plane, so that at any time t, the position of the particle is given by x of t equals t cubed plus 4t squared, and y of t is t to the 4th minus t cubed. It says find the velocity vector at t equals 1. So remember, to find your velocity vector, you have to take your derivative of each piece. So our velocity vector is dx dt and then dy dt. Well, dx dt is 3t squared plus 8t, and dy dt is 4t cubed minus 3t squared. Notice I'm using the triangle brackets to show that this is a vector in its component form. Alright, now if I want to find the velocity at 1, I plug in 1 into my function, so I get 3 plus 8, and then 4 minus 3, which is 11, 1. Alright, the next part of this says find the acceleration vector when t equals 2. Now remember, your acceleration is the derivative of your velocity. So it's the derivative of your position functioning. So if I take my velocity function and take that derivative, I get 6t plus 8, and then 12t squared minus 6t. If I want to add 2, I'm going to plug in 2 into my function to get 20, 36. So 20, 36 would be my acceleration vector at t equals 2. Right, example 2 says a particle is moving in the xy plane, so at any time t greater than or equal to 0, the position of the particle given by x of t equals t squared plus 3t, and y of t equals t cubed minus 3t squared. Find the magnitude of the velocity vector when t equals 1. So the magnitude of any vector is the square root of each component, the derivative of each component squared. And so the square root of dx dt squared plus dy dt squared. And so remember, dx dt is 2t plus 3, dy dt is 3t squared minus 6t, and so our magnitude is going to be square root of 2t plus 3 squared plus 3t squared minus 6t squared, such that t equals 1. And so if I plug in 1 into that, I get 5 squared plus 3 squared, or 25 plus 9, which is the square root of 34. All right, in example 3, it says the particle moves in the xy plane so that x equals the square root of 3 minus 4 cosine t, and y equals 1 minus 2 sine t, where t goes from 0 to 2 pi. It says the path of the particle intersects the x-axis twice. Write an expression, but do not solve, do not evaluate. Write an expression for the distance traveled by the particle between the two x-intercepts. All right, so the path of the particle intersects the x-axis wherever your y component is 0. So your x-intercepts is when y equals 0. And so what I'm going to do is I'm going to take my y equation, I'm going to set it equal to 0. So when I do that, I get sine of t equals 1/2. And I know for my unit circle, t must equal pi over 6 and 5 pi over 6. Alright, so we're trying to find the distance traveled from the object between pi over 6 and 5 pi over 6. And so basically I'm going to set up like my arc length formula. So I have the integral from pi over 6 to 5 pi over 6 of the square root of dx dt squared plus dy dt squared. Remember, dx dt is 4 sine t and dy dt is negative 2 cosine t. So the expression for the distance traveled would be the integral from pi over 6 to 5 pi over 6 square root of 4 sine t squared plus negative 2 cosine t squared t. All right, example 4, an object moving along a curve in the xy plane has position x of t, y of t at time t with dx dt equals sine t cubed and dy dt equals cosine t squared. At time t equals 2, the object is at the position 1, 4. So the first thing it asks for is the acceleration vector. for the particle at t equals 2. And so I know that the velocity, because they gave us dx dt and dy dt, I know the velocity is sine t cubed cosine t squared. So if I want the acceleration, I need to take the derivative of that, making sure to use chain rule. So I get 3t squared cosine t cubed minus 2t sine t squared. And then I want that at 2, so I plug in 2 everywhere. And I get that a of 2 is negative 1.467 and 3.027, obviously using a calculator. The next problem says write, and that should say part B, it says write the equation of the tangent line to the curve at the point where t equals 2. Well, first thing I need to figure out is dy dx at 2. And so remember, with our parametric equations, that we have the same derivative. Dy dx is going to be dy dt over dx dt. So dy dt was cosine t squared. So dy dt at 2 is cosine 4 over dx dt, which is sine t cubed, or when t equals 2, it would be sine of 8. And so plugging that into the calculator, I get negative 0.661. Which means that the equation of my tangent line, since we're at the point 1, 4 when t equals 2, would be y minus 4 equals negative 0.661 x minus 1. All right, so continuing with example 4, it says find the speed of the vector at t equals 2. And so remember, speed is just the magnitude of your velocity. And so remember, our velocity function was sine of 8 and cosine of 4 at t equals 2. So speed is going to be the square root of sine of 8 squared plus cosine 4 squared. Plugging that into the calculator, I get speed approximately equals 1.186. All right, and the last problem, for example 4, it says find the position of the particle at t equals 1. So your position is going to be whatever you start at when at x equals 2 minus the integral from 1 to 2 of the derivative of x. And the same thing for y. In other words, we're integrating the velocity function and we're taking into account its original position. So almost like your plus c. And so when I do that, I get 1 minus integral from 1 to 2 sine of t cubed dt. For your x, and then for y, we get 4 minus integral from 1 to 2 cosine t squared dt. And again, working that out in my calculator, I get for the x component 0.782, and for the y component 4.443, which tells me that the position at time t equals 1 is 0.782 and 4.443.